Welcome to Petro-Explorers. Petro-Explorers is a leading provider of integrated reservoir characterization services. The company was incorporated in 2009 in Calgary, Canada. The company's goal is to create value for customers by providing tailored reservoir characterization through application of leading-edge technologies and in accordance with the industry standards. Petro-Explorers offers its services to the exploration and development companies of different sizes, both locally and worldwide. For the last 12 years, we have provided services for more than 50 clients covering many basins of the world. Since its creation, Petro-Explorers has been vigilantly working towards establishing networks of partnerships and business affiliations. The company has established solid network of consulting affiliates such as Rocky View Geoservices, Canadian Reservoir, Launchout Geo, JAGTAC. Internationally, we work with OGIS in India, Exploration Systems in Norway, and an agent in South America. Petro-Explorers team usually markets its services through participation in annual events such as GeoConvention Conference in Calgary and AAPG ICE. For years, Petro-Explorers and DGB Earth Sciences have been appreciating close mutually beneficial business collaboration. Petro-Explorers is a Canadian agent of worldwide renowned OpenDetect software, innovative seismic interpretation engine developed by the Netherlands-based DGB Earth Science. We offer extensive quantitative and interpretive reservoir characterization services. Some of the services provided as standalone or as a whole workflow to identify the drilling prospect from the getting data to drilling location. Let us look at the services in more detail. Quantitative interpretation, rock physics, modeling, and inversion. AVO analysis requires careful modeling and gathers conditioning to reveal the best combination attribute that would differentiate the hydrocarbon-bearing reservoir from its brine counterpart. Application of rock physics and modeling is key to distinguishing the lithology and fluids. In AVO feasibility studies, careful conditioning of the gathers, amplitude-preserved processing, and modeled calibration of wells can define fluid separation capability of seismic pre-stack data. Post-stack deterministic inversion is used to separate lithology, leading to better interpretation. In Llanos Basin of Colombia, post-stack inversion allowed differentiation of sand and shale-filled channel systems. Pre-stack simultaneous inversion allows differentiation of fluid and lithology at the same time. Pre-stack inversion has been proven as the best tool to reduce the exploration risk. Neural network inversion allows the conversion of inversion results to the rock and fluid properties such as porosity and volume of shale. Multipoint stochastic inversion is another tool to quantify the uncertainty for reserve estimates. The process of hit-cube stochastic inversion is based on simulation of rock properties within a stratigraphic interval such that all the possible variations are captured and their probabilities are defined. Pseudosynthetic traces are generated, and then the traces are matched with real seismic data in the framework of the geological model. The best matches or hits are then used to create inverted property models and their probabilities. Example is from Western Canada glauconite unit. Fault and fractures characterization is another important area for conventional and unconventional plays. We apply advanced fracture identification techniques such as various volume curvature analyses. Curvature analyses can lead to removal of footprints and thus preserving the geological discontinuities. Similarity coherence attributes are key to structural analyses but do have their limitation. Thin fault likelihood provides fault and fracture probability along with their azimuth and dip. The fault planes can be classified and extracted according to their dip and azimuth direction and can also be filtered based on their likelihood value. To help interpretation on conventional software, we can embed the fault signature on the seismic called fault-blanked seismic volume. Fault and horizon interpretation work led to additional fault blocks in CHAD. As for the unconventional fault/fracture analysis in combination with spectral decomposition can help in detection of the sweet spots and fracture network as carried out for one of our Montney shale player in Alberta. Fluid migration and chimney analysis is another area where we have worked together with DGP Earth Sciences to reduce exploration risks. Subsurface fluid migration pathways can be detected using neural network method, the chimney cube, which identifies hydrocarbon migration pathways and seal integrity. In Gulf of Mexico, chimney cube has been used extensively to de-risk fault seals. In an Anza Basin exploration project, Petro-Explorers team was able to use the fluid migration analyses to focus the exploration. Another service that is an integral part of reservoir characterization is quantitative sequence stratigraphy interpretation. Sequence stratigraphy helps to build comprehensive geological model. There are two mutually dependent workflows through seismic and wells. We have converted the whole workflow into small automated modules. We have developed an in-house automated top correlation module where only few reference wells are required to pick tops on thousands of wells. Corrected log data is automatically converted to petrophysical derived logs. This is followed by automatic identification of sequence stratigraphic surfaces, major flooding surfaces, and sequence boundaries. Seismic is automatically processed to achieve Wheeler diagram and horizon cube, a relative geological time volume. Most of the above analyses are done using our proprietary automated sequence stratigraphy package, QStrat. Automatic sequence stratigraphy was carried out into carbonate deposits of Newfoundland. Better identification of shale barriers in oil sand was carried out through the use of automatic sequence stratigraphy. Advanced seismic attributes analyses. Various attributes allow better visualization of seismic data, such as pseudo-relief, co-rendered with seismic amplitudes. Curvature attributes such as Gaussian curvature can highlight the karsting features in carbonates. Mixing spectral frequency bands can highlight various seismic geomorphological features. RGB blending is a method that can be used with many attributes. Through spectral decomposition, meandering's fluvial system of Carbonara Formation is revealed and shown in comparison to present floodplain deposits. Multi-attribute visualization is key to reveal the hidden seismic architecture. Another important mature machine learning technology is waveform facies analysis. You can see a meandering Notiquin channel meandering revealed by seismic facies map. In some areas, the thickness of sand is buried within a wavelet. Seismic facies is shown to reveal the sand isopack within Cardium sand, clearly highlighting the sandbar and lagoon. Multi-attribute machine learning allows segmentation of data that is more meaningful. Let's take a look at another area of service providing. Petro-Explorers for years has also been offering support for bid rounds, field development plans, and reserve evaluation. As an example, Petro-Explorers is the leading provider for FDP, field development plans in India, the plan submitted to governmental body which is required for any Indian company to get approval for development of their fields. To date, in DSF rounds 1 and 2, Petro-Explorers along with our partner OGIS have completed the most FDPs than any company providing such services in India. Petro-Explorers' team is trusted worldwide to reduce exploration and development risks through the use of leading-edge technologies and in-depth experience.